Our next section of chapter 6 is the triangle mid-segment theorem. And what it tells us is that to find a mid-segment of a triangle, it's a segment that connects the midpoints of two sides of the triangle. So for instance, on this side right here, if I look at side AB, M is the midpoint. And I know it's the midpoint because, again, I see these two pieces are notched and they're equal. So this means this is the midpoint. And then if I look at this side over here, this side BC, I can see that P is the midpoint. Again, I know that because of these notches stating that those two pieces are equal. So this MP right here is considered a mid-segment because it connects this side with this side, and it's connected by their midpoints. So every triangle, so another piece of this, has three mid-segments. So you can see I did that on this side as well. From this side to this side, I connected their midpoints. So this is another mid-segment. NP is another mid-segment. And then from this side to this side, I connected, and MN is also a mid-segment. There's a couple of things that are important about mid-segments. As we just stated, the three mid-segments of ABC are these. I put them in green to kind of match my three mid-segments there. And the mid-segment triangle is created inside of here. So I can see that these three together create another triangle, and it's called the mid-segment triangle. And for solving, so some examples that we're going to do in big ideas, we're going to need to use the midpoint formula because we'll have these 2 points. For instance, like we'll have BC, and they'll ask us to find the mid-segment, which means I need to find what this midpoint is. So remember, just as a reminder, you're going to need to use the midpoint formula to solve those. The next part is this guy right here, and it is theorem 6.8. Let me adjust that a little bit differently there. And in 6.8, it's called the triangle mid-segment theorem. So again, it tells us a couple of things. It's all about the mid-segment today. It's the segment connecting the midpoints of two sides of a triangle. Okay, so I know that. We already talked about that in the last piece, but this theorem extends it a little bit. So the first thing that it tells us is that that mid-segment is parallel to the third side. So since I connected these two sides, their midpoints, to create my mid-segment, now I can say that this mid-segment is parallel to the third side. So you can see, remember those little arrows notch that those are parallel. The other thing that it tells us helps us a little bit with the solving in the algebra, what I put in green. It's also half as long as that side. So this mid-segment is exactly half of this third side. So for instance, if I know this third side is like 10, then I know this guy is going to be 5, which of course helps us with some solving. So those were the two big things of this theorem. One is that the mid-segment and the third side are going to be parallel, and that the mid-segment is half of the third side. So an example. So let's take a look at an example that we could see with our notes. So here's exactly what I was just talking about. So this is a mid-segment. They tell us that in the example that DE is a mid-segment. Since DE is a mid-segment, I know that it is half of the third side. So I just take half of 26, and I know that this side right here is 13. The other example, again, they tell us that DE is a mid-segment. So this guy is a mid-segment. And remember back in the early part, if this is a mid-segment, it means that E here is a midpoint. So if I know that this side is 6, then I would also have to know that this side is 6 as well. So if they ask me to find AC, which is this whole piece, I would be able to solve and say that both sides together are equal to 12.